Okay, let me show you the question quickly in the book before we open the whiteboard. So the question is, solve each system by graphing if the system is inconsistent or the equation or independencies. Okay, so solve by graphing. We just solved a system in the previous example, but it was by substitution. Okay, so this time we're doing graphing, so we're not actually solving the problems themselves like we did earlier, but we're gonna have to graph both lines and see, as I mentioned earlier, whether the lines intercept on one point, parallel, no interception, or the two lines overlap, therefore many solutions. So let's scroll down. Marie is asking about question number 37. 37 is this one. It's a system of two equations. You're going to solve it by graphing. So instead of doing that,
it's 43, not 47.
43. Okay.
Yes.
This one. Okay, 43. Let's do 40. I mean 43. Let's do 42. Or maybe, so the closest one is this one. So 42. Okay, let me open the whiteboard. And where is it? All right, so this is unit 4.1. Question number 42. Okay, so I'll do 42 and you'll do 43 for the homework. So solve this system by graphing. Okay, it's important to solve by graphing, not substitution as we did earlier, not elimination, but by graphing. So we have two equations of x plus 2y that's a 2. This is okay, so that's a problem. 2y, blah, blah, that's it. All right, so by graphing. So when you solve by graphing, that means we need a graph for these two lines. So, so to graph these lines, we need to find some points. We need to find some points first. So the line again, the lines might, these three cases. So the line might end up like this, intercepting. So this will be the solution S. Okay, with a pair of points X and Y. The two lines might be parallel, so no solution. Or the third case is when you graph, you draw the two lines, they end up parallel, not parallel, but they overlap like this. One over the other. In this case, you have many solutions. Okay, three possible cases. Let's say which one it is on this equation. So we're going to have to graph all of them. So graph line 1, which is basically this equation x plus 2y was 4. So to graph a line, you can use the right on a run if it's in the y mx plus 4, or you can use the you can complete a table if you're given a table of incomplete pairs. If you don't have that, you can make up your own. In this case, we're not given any pairs, so we can make our own pairs. We need at least 2 pairs, 2 points to draw the line. So this is what we call the x-intercept. Put 0 on this is the x, and this is the y. So put 0 on the y, so that's the x-intercept. Okay, so what we call the x-intercept. Then the other pair, this time we're going to put 0 under the x. This is what we call the y-intercept. Okay, once we complete these pairs, we can graph the line. So we're missing x here and we're missing the y. That's the equation. We made up a couple of incomplete pairs. How do you find x knowing the value of y, which is 0? How do you find it here? So x is unknown, the y is 0, this here. So what do we do with the y and this equation in order to find x? Everybody?
You plug it, plug the Y.
We're going to plug it, plug the y since we know it, we're going to plug it here. This will cancel out because y is 0, then the x will be, the x will be the x plus. So this equation turns into 2, that's right, that's right. So we're going to substitute this into this, it will be 0, 4. That's the reason why we use these intercepts. They're easier because the zeros cancel numbers out. You can use any numbers you want, or you choose and find the others, but it's always easy to start with the intercepts, the x and y intercept. I'll tell you later why we call them so. That cancels. X is 4. So the missing number here is 4. Let's repeat the same thing here. This time we know the x. That's what we call this point is called the y-intercept because the x is 0. We need to find y. Same way. So we're going to take the value here. So this time we know the x, but we're missing the y. So we take the x again and we plug it into the equation here. So what would that be? X is 0 plus what? 2 times. Do we know the value of y? No, we don't know. That's what we're trying to find. So we're going to do this. So 0 plus 2y is?
2y.
Right, 2y and 4. Finally,
Divided by 2.
Divide by 2, divide by 2. These cancel out. So y is 2. So once you find both, okay, so the y, we found both x and y. So the y goes here. Okay, so the y was missing. So that goes here. And this x is what was missing, and it went over here. Okay, that's line 1. Okay, all this just to graph one line. What are you doing next? What happens next, everybody?
Did you graph it or you do the second one? I don't know.
Let's use the second one. Let's do the second one and then graph both. So far, one is complete. We're going to repeat the same process with this one. So this equation here. We're going to do the same thing as here. We're going to complete 2 other pairs. Then we're going to graph all on the same line. Okay, so graph line 2.
2x plus y equal to
Is everybody okay? Joanna, Lydia, Sharon?
Yes. Yes.
Any questions?
Yes. Okay.
Okay. All right, so let's graph the second line, which is this one, 2x plus 4y equals 12. Same way. What do we need again to graph this line? Just like we did here.
x-intercept and y-intercept.
That's right, we're going to need 2 intercepts, incomplete pairs. X-intercept means what? Which one is 0?
The y.
The y is 0, that's right, just like here. And the y-intercept means?
X.
The x is 0. So we're just going to need to find this and find this. Same way we just did. So let's find So let's start with the first, let's complete the first one. So this time x is unknown, but the y is 0. So we're going to plug, again, we're going to plug this, the y into the y, and solve this to find the x. It'll be 2, we don't know x, plus 4 times what?
0.
0, that's right. The 0, this 0 from here goes into that. And what else? So that cancels. So 2x equals 12. That means x is?
6.
X is 6. That's what goes here. Okay, so we completed this point. Now we're going to need to complete the second one in the very same way. So we're going to do this time for the y-intercept. It means the x is 0. We don't know the y, so x is 0. The y is unknown. The same thing, we're going to take that. We're going to take the x this time. We're going to plug it here and solve this for the y. Let me know if something is not clear at any moment. Please feel free to stop me and interrupt me. So 2 times x, the x again is 0, plus 4y, is equal to 1. What does that mean? That cancels. So 4y equals 1. Okay, because again, the
12.
x. Did I miss the 2 here? Did I miss a 2? That's right, it's at 12. Thank you. It's at 12 here. 4y times 12, that means y is what? The y is?
3.
3. That's right. If you divide both sides by 4, you get 3. And our second pair is complete. Okay, so we graphed. Again, that's the system. It's a lot of work, I understand. That's by graphing. So two equations. We completed the pair for each one. So we know we have enough information to graph both. We completed the pairs for the first one, the second one. What do we do now with those pairs?
Plot it on the graph.
That's right, exactly. We're going to plot all these points in a graph, and basically we're going to have 2 lines. We're going to have 2 lines here. So we're going to need a bidimensional graph, an x and y graph, L1 and L2 on the same It has to be the same graph, okay? Otherwise, you won't see the solution or the intersection. Let me make a 2-dimensional graph. So it goes something like this. 2 perpendicular lines. One is called which axis? There's 2 axes here. One is the x. The other one is
Y.
the y. And we can go ahead and just put some numbers here. You can use graphing paper if you have it, which you can easily print online. If you go on Google, just type graphing paper and pick one that has 9 graphs or 6, whatever. Or if not, you can make up your own graphs like this. So we have positive numbers here, negatives. What's the center? What's the number in the center of the graph?
0.
0. Both x and y are 0 here. We have positive numbers up, negative down. All right, let's put our points here. Start with the first line. The first line, we have 2 points.
0.
Okay, that's the first line here. We have 4 and 0. How do you graph 4, 0? So the x is 0, 4, the y is 0. Where do you start from?
The x.
Always locate the x first on the x-axis. On what side will the 4 be?
All right.
All right, 1, 2, 3, and 4. So this is 4. And the y is 0. So the x is 4, the y is 0. Where do you go from here?
Nowhere.
Nowhere, we stay over here. If the y was a positive number, it would go up. If it's a negative number, it would go down. But if it's 0, you stay on the x-axis. So that's the first point of the first line. Then go to the second one, 0, 2. We want to graph 0, 2. Where do you start and where do you go? I want to hear from all of you, not just Marie. What to graph 0, 2, where do you start and where do you go?
You go to the 0 on the x-axis and go up 12 to the y-axis.
Exactly. We're going to start from 0 and go up. Please, Gianna, do you have some background noise there?
Yes, I'm sorry.
Yeah, could you please mute that? So we start from 0, as Gianna said, 0 on the x-axis. The 0 is always in the center of the graph. And then since the y is a positive number, so we're going up from the 0, we're going up 2 units. If it was negative, we would go down. The reason we stayed here earlier, because the x was 4, the y was 0, so we stayed on this point. So that's basically the first line. Let's graph that line. Nope, not good. I need a straight line like this. Okay, that is, let's call this line 1. Good, so we're going to repeat the same process with line 2. We're going to do this in a different color. Let's say maybe something we haven't used. Okay, pink looks good. Okay, that's line 2. Line 1 is done. It's here. Now we're going to do line 2. So we want to graph, want to plot to this point 6, 0. Again, where do you start? Where do you go?
You're gonna go to 6.
Lydia, say it again.
On the X line, 6.
That's right. And then?
And then 0 with a Y line.
We stay, that's right. And we
Right,
stay on the x-axis.
0.
Okay. So the 6 will be right here, 4, 5, 6. So this is 6. Graph or mark that point. Second one is 0, 3. So we start from 0 in the center. Where do you go from there?
3.
2. We go 2. Up. How many units?
2.
Not 2. Start from here. We go 2.
3.
3 units. So here, up. 3 units. And let's grab that line. Let me grab a straight line. And it's going to be something like this.
Parallel.
Okay, what did you say, Marie?
It's parallel.
Parallel. If it's parallel, what does that mean?
No solution.
Exactly. As we saw earlier, there was 3 cases. One solution here. If you have the lines meet on 1.1 solution, if they're parallel, there is no solution. If you end up with the same line, you say many solutions. For example, if for some reason this pink line ended up being the same or over the line 1, the red one, then it would say many solutions. So let's just say no solutions. No solution. The lines never meet. In math, we say that they're parallel. Parallel. Don't meet. Don't meet or don't intersect.
Intersect.
To use more of a technical term. Intersect or intercept with a P, intercept each other. And that's basically how you graph or how you solve linear systems using graphing. So you got to stick to the method that the question is asking you to use. It could be graphing like we did right now. It could be by substitution as we did earlier, or it could be by elimination, which is another method of solving linear systems. Okay, that's a lot for a question, but again, there are different methods. That's why we prefer one over the other. So you need to know all these methods. Depending on the system, one of them can be easier to use over the other. So we need to know all of them. And by experience, you'll see that it's easy and becomes counterintuitive to figure out which method works for which equation.
Thank
Okay,
you.
does that make sense to everybody?
Yes.
Thank
That's
you.
okay.
Yes.
Gianna, Marie, all good?
Yes, thank you.
Yes.
Right.